Okay, this is Doc Scientia. It is exercise 18, question number 2. You can see that I've put the text for this question here down at the bottom of the graph, and it's really small, so hopefully you've got your textbook open in front of you so you can follow what's going on here. It says to you, a car initially travels in a southern direction after starting from rest. So let's take that piece of information and look at what's going on here. It says to you the car is traveling south, and the very first part of this graph from A to B, you can see it has a negative slope. So if the graph is negative and it's going south, that must mean the positive is going to be north. So for this whole graph, anything above this axis, okay, this is north up here, and this is south down here, because that's how a velocity time graph works. Because when we have a velocity time graph, the sign of the velocity depends on the direction the object is moving. So the first question asks you over here, which section of the graph indicates movement to the south? So this to the south, 2.1i, to the south is everything under the graph, which is this section. All of this section here will be south. So A to B, B to C, or you could just write A to C. That is all south. Then what is going to the north? It is everything above the graph. So it is all the way from C all the way to F. That is going to be to the north. Then it says to you, where is it traveling at a constant velocity? Now remember, for a VT graph, okay, a velocity time graph, the area under the graph is equal to the displacement, and the gradient of the graph, you have to remember this for all VT graphs, the gradient of the graph is going to give you acceleration. So at a constant velocity means acceleration is 0. So where is the acceleration 0 on this graph? The acceleration is 0 over here where the graph is flat. So if you want to answer this question at constant velocity, that will be D to E. Then it says, describe the movement of the car fully for the following sections of the graph. Give directions, velocity, acceleration, etc. Now these are not marks for free here, okay? You have to be careful what you say in these graphs. So in the beginning it says A to B. So this section here is A to B. So we need to describe this as well as we can. So you can see that my initial velocity over here was 0. So we went from rest, we traveled south. We know we traveled south because that's what the question tells us. And when we were traveling south, we must describe what we were doing. Were we traveling faster? Were we traveling slower? And this is where you need to bear in mind that velocity is a vector. So this negative 20 actually just means it is a big velocity in the southern direction. So we were traveling south and we were accelerating positively, well, we weren't accelerating positively, that's a lie. We were traveling south and we were increasing speed. We can say we were increasing speed, that's not a lie. We were increasing speed to 20 meters per second, but now we must qualify this 20 meters per second. It was 20 meters per second south, okay? We know this because it is negative. So we can say we were accelerating in a south direction, okay? In a southerly direction. Now it says to you what's going on from B to C. Now this is where it gets confusing now, yes? You can see that this section of the graph has a positive gradient. But what you have to remember is that we are still below the axis. So remember, this is all south, this is all north. So from B to C, okay, we were still traveling, because remember we have to say what we were doing. We were still traveling south, okay, because we're below the line, but we were having acceleration that slowed us down, okay? So we can say, but the speed was decreasing from, what were we, 20 meters per second south, 20 meters per second south, to rest at 8 seconds. Okay, so we need to say, describe what was our initial velocity, 20 meters per second south, and then at C we were at rest, so we were decelerating, or the speed was decreasing from B to C. Then it says to you, what is going on at C? This is C over here. Now C is quite literally a turning point. You can say at C you are at rest because the velocity equals 0 meters per second. But what is exactly happening at C? In this moment, just before you got to C, you were traveling south, and in this moment, just after you got to C, you were traveling north, because remember, everything under the axis is south, everything on top of the axis is north. So at C, you changed direction. You momentarily stopped, and then you changed direction. Okay, then what's going on between C and D? Here is between C and D. Now we have gone from 0, okay, to 20 meters per second in a northerly direction. Okay, you must make sure you state the direction. You can say between 8 and 11 seconds, but because it says to you in the graph between C and D, you can just use between C and D. You went from 0 to 20 meters per second in a northerly direction. So in this case, you were accelerating to the north. Or you can say you were increasing your speed or increasing your velocity. But it's better to say actually increasing your speed at this point. Then it says to you, what is going on between D and E? So you can see between D and E, which direction are you traveling? You're above the axis, so you are traveling north, okay, at a constant velocity of 20 meters per second. Then finally it says to you it says to you what's going on between E and F. So describe what's going on between E and F. You are slowing down from 20 meters per second to 0, but traveling north. While traveling north, so you are slowing down in a northerly direction. Okay, and then finally the last part says what is going on at F. Well, at F here, you can see F under all my chicken scratching. At F over here, you have come to a complete stop. You are just completely stopped because you can see the car journey has come to an end. So that would be the answer for that. Now I'm going to rub all of this out. So if you want to try and read my chicken hand scratch writing, what you need to do is you need to stop the video here and copy down whatever you're confused about, or replay it so you can hear what I said, because I now want to do the calculations and I want a nice clean graph to work from. So let's get rid of all the writing here. Now it says to you calculate the total displacement of the car during the 22 seconds. So remember, for a VT graph, this is a velocity time graph, acceleration equals the gradient of the graph because it's the change in velocity with time. And then how do we find the displacement? The displacement is always the area under the graph. Okay, so now it says to you calculate the total displacement. So we're looking at this area here, which is under the graph, and this area here, which is under the graph. So depending on which formulas you know to calculate what, depends on what you can use. But for now, let's have a look at this one over here. This is very clearly, I hope you can see, look, here is a triangle. Can you see this triangle here? So with this triangle, we know the formula for area of a triangle is a half base perpendicular height. So from the base is going to be from 0 to 8, so it's going to be a half of 8, and the perpendicular height over here is negative 20, so this is going to be negative 80 meters. Then in this section over here, we've got this triangle, this rectangle, and this other triangle, if you don't know your formulas for trapeziums and stuff. So this triangle over here is half base times perpendicular height, so it's a half of 3. Remember 8, 9, 10, 11 is times 3. And then over here, this is 20. So half times 3 times 20 is 30. Inside this one over here, it's a rectangle, length times breadth. So 11 to 17 is 6 times by the height here, which is 20. So this is 120. And then finally the last triangle is a half base perpendicular height again. The base is 17 to 22, which is 5, and the height is 20. So this one is 50. So to calculate the displacement, we need to take into account that displacement is a vector. So this area here, over here, that's under the curve is going to be negative. So it's going to be negative 80 plus 30 plus 120 is 150, plus another 50 is 200. So it's negative 80 plus 200, which gives you 120 meters. Now this came out as positive, so we need to know which direction is positive because displacement is a vector. So it is 120 meters north. Then it says to you, what is the total distance covered by the car in the 22 seconds? For the distance is a scalar. We don't care about the direction, so we turn this negative 80 into a positive 80, and we add 200. This is now 280 meters, and because it's a scalar, we just need to give it in the correct unit. Now it says calculate the average velocity of the car. So the average velocity is the change in displacement over the change in time. So we take this displacement value here, which is 120, and we take the time, which is 22 seconds, and then you put your numbers in the calculator and you come out with 5,45 meters per second. But velocity is a vector, so we need to say that it is 5,45 meters per second north because it is a positive value. Now it says to you, calculate the acceleration for the following sections of the graph. So let's have a look at the graph again and which sections they want us to calculate the acceleration on. The first part, it says A to B. Now look here, people. This is a negative slope. You better make sure that your answer is negative and that you give the sign acceleration is a vector. So we need to state that acceleration is the gradient, and then we use some form of the gradient formula, dy dx. And now we are going to substitute in values from the graph. So this point over here is 0, 0, and this point over here is 5, negative 20. Okay, so we're going to say dy dx, and if I take, this is the first point here, this one over here is the first point, I'm going to say 0, subtract negative 20 over 0, subtract 5. So I get 0 minus 20 is positive 20 divided by negative 5, and that is going to give me negative 4 meters per second. So I'm going to not write this as negative 4 meters per second. I will say for AB, the acceleration is 4, oh, it's not meters per second, sorry, it's meters per second because it's acceleration. It's 4 meters per second, and it is south. My value was negative. Acceleration is a vector, and in this question, south is negative. Then it says to you, calculate for BD. So here is BD on your graph. You can see this is a positive acceleration. So you can find the coordinates of point D. Point D is 11, 20, and we already knew point B was 5, negative 20. So we're going to do the same gradient calculation again. Let's try and find some space to do this gradient calculation. What will it be here? We're going to say acceleration equals the gradient, which is dy dx. Always give a version of you can say y2 minus y1 or x2 minus x1, whatever you're comfortable with using as your gradient formula. So we're going to say 20 subtract negative 20, those are my two y values, over 11 subtract 5, and I end up with 40 over 6, and if I put that into my calculator I get 6,67, and it's an acceleration, so it's meters per second, and because it is positive and acceleration is a vector, we are going to say north. Okay, and then finally it asks you for EF, and once again we've got negative acceleration, so we need to find the coordinates. This one is 17, 20, and this one is 22, 0. So the acceleration EF is once again going to be dy dx, and then my first y value is 20, my second y value is 0, my first x value is 17, my second x value is 22, end up with 20 over negative 5, so I end up with negative 4 meters per second. I need to convert this into a magnitude and direction, so it's 4 meters per second, and it is southwards, so the acceleration is opposing the motion. Okay, now this last part is quite needs a little bit of thought applied to it, so I'm going to get rid of all the ink on this graph and we're going to have a look again. So if you wanted to copy something down, stop, rewind before I erased it all. Okay, now it says to you, draw a neat sketch graph for the following. So on any sketch graph you don't have to give the values, but you actually have to show you know what you're doing, okay, where the points are, and label the axes. So first of all it says position time from C to F. So you can see that they're talking about this whole section of the graph here. Okay, so the first thing we need to look at is displacement is a vector, and so is velocity, and displacement you will have declared which direction is positive, and in this question they've said that north is positive. So to prepare for the graph, we first check, is everything above the line? Everything is above the line. So when we draw a displacement time graph, or position time graph, we are only going to need the first quadrant of the graph that is positive. So this is going to be position, and we're going to mark it in meters because it wants you to label the axis, and this is time in seconds. So we are starting at C, so at this point on the graph it is C. Now C, there was no velocity, but we were from C to D in this section of the graph over here, from C to D, you can see we had a constantly increasing velocity. So if you have a constantly increasing velocity, that means you are accelerating, because the rate of change of velocity is acceleration. So if you have a positive acceleration on a distance time graph, you come up with this curvy shape. You remember it's an increasing curve. Okay, so from C to D we have a curve. Then from D to E, can you see from D to E the graph goes flat, and the car is traveling at 20 meters per second, which means that every second we are 20 meters away from where we went. It is a constant acceleration, so instead it's a zero acceleration. A constant velocity is a zero acceleration. So a constant velocity graph is a straight line, so this next bit you have to draw with your ruler. Okay, I'm not going to accept it if you don't draw it with your ruler. Constant velocity means that you have a straight line displacement time graph. Now finally, in the last section over here from E to F, you can see that the velocity is decreasing. So if the velocity is decreasing, we have to draw the decreasing displacement curve. Every second you are displacing a little bit less when you slow down. Think about a person walking slower and slower and slower, and if you time them, the distance they walk per second gets smaller. So the graph is going to show this decreasing trend. So something like that. And that will be now your time F. So make your sketch graph a little bit better than mine. You can work out this 8, 11, 17. You can work out the distances where you have to have the upward curve, the straight line, and the decreasing curve, so that they are all nicely lined up. Okay. Alright, so that's the position time graph. Now it asks you for the acceleration time graph. So before you start doing this, you actually have to think quite hard. What exactly is going on? So over here, the car, if you think about it, the velocity value, the magnitude of the velocity is increasing. So that means you've got acceleration in the same direction as the velocity. So this is acceleration in a southerly direction, okay, from A to B. This is southerly acceleration because the car is getting faster while it's traveling south. In this section, the car is still traveling south, but it's slowing down. So to slow a car down, the acceleration must oppose the motion. So this is northerly acceleration. Now over here, remember the car changed direction. It came to rest and then it changed direction because now we flipped over the graph. And then it started getting, over here, it was getting faster. Okay, so this is then northerly acceleration. In this section over here, there is zero acceleration. Remember, because we're traveling at a constant velocity. And then over here, the car is slowing down again. So when the car is slowing down while it's traveling north, this means the acceleration must be to the south because the acceleration is opposing the motion of the car. So if we draw this graph, can you see here? Let's highlight the southerly acceleration, and southerly acceleration. So because acceleration is a vector, okay, because acceleration is a vector, we are going to have to draw that below the axis. So when we draw our graph now, we're actually going to draw the time axis, the time in seconds, is actually going to end up in the middle of our graph. Okay, acceleration is measured in meters per second per second. So we can label the points on our graph. We could go, here was A, here was B, C, D. Oh, I've not planned this very well. Let's see if I can plan this a bit better. So let's bring B a bit closer. B, C, D, and then this section was a little bit longer, and then F. Okay, so I've got my graph here, and remember now, we worked out first of all on the graph here, that this is southerly acceleration, okay, but you can see it is a straight line, and this is also southerly acceleration, and it's a straight line. And if it's a straight line, it means it's constant acceleration. So a constant acceleration graph is going to be a straight line. So from A to B, okay, we are traveling at a constant acceleration in a southerly direction. From B to C, and then from B to D, in actual fact, check here, the whole way from B to D, we are actually traveling at the same constant acceleration. So from B to D, we're going to draw a line above the graph. Okay, and you can join the line below and the line above with a little dotted line, or you can just leave it blank. Then from D to E, you stopped accelerating, so 0 acceleration. You're going to draw a line on top of your x-axis because that's where it's 0. And then finally from E to F, you started accelerating in a southerly direction again, and there you have a southerly acceleration, which is shown as being below the graph, and that is your whole acceleration time graph. So remember, with all of these graphs, that if it's a VT graph, always start out by saying the area under the graph is going to be your displacement, and the gradient is going to be your acceleration. So a negative gradient implies negative acceleration. A positive gradient implies positive acceleration. A 0 gradient means 0 acceleration. And finally, a negative gradient is negative acceleration. And of course, you know that you have to be working on this based on what is in the question. Has the question given you which is your frame of reference for the direction of motion, which direction of motion is positive?